Now, can you see the screen?
Yes, sir.
Yes, sir.
Okay, okay. So what we were doing, what I was telling, oh, it's almost time. Therefore, the structure of glucose exists as six-membered hemiacetal. Now, what happens when when any one NMR is dissolved in water, it quickly opens up to give us the open chain form and then closes to give the alpha and beta glucose. The changeover will take place till the equilibrium is reached. At equilibrium, there is about 36% alpha, 64% beta, and only 0.02% open chain glucose. This is also the reason for mutant rotation of glucose. So I think so. Here, what we find, so as soon as suppose I take alpha glucose in solution, dissolve it in solution, it was 100% alpha glucose at the beginning. But as soon as I dissolve, it first of all opens up like this because it is in equilibrium with this. It is in equilibrium with this one. But this is not a stable structure, so it closes again. But when it closes, it will go both alpha as also beta. So as a result, what happens when initially when there was 100% alpha, it starts producing beta as well. So this will continue till that equilibrium is reached. And at equilibrium, what is formed? We find that about 36% of alpha glucose and 64% of beta glucose is there. And that will give, because of this, there is the change of specific rotation happening. And the mixture of these two is going to give you that equilibrium value of the specific rotation, that is plus 52 degrees. I'm going to give you a problem also. I'll send it today, how to establish this final value of 36 and 64 later on in that. So what we find now quickly, okay. All these apparent anomalies that we have seen now can be explained. How? Let us see this. This is now what is actually happening when a glucose is reacting. Glucose is present as, if you take alpha glucose or beta glucose, suppose you take beta, you take beta glucose, it is coming to open chain, it is also coming to alpha. So everything is there. Now, depending on, suppose you have reacted with bromine water. So what bromine water is going to do is going to oxidize the aldehyde group. So it is this form which is going to react, which will going to react and give you that. When you react with NH2OH, it is the aldehyde group which is going to react, aldehydic form which is going to react, and ultimately you get glucose oxime and 100% glucose oxime. Not that, because everything will get converted into open chain and it will go to this. Because equilibrium will keep on shifting, and as soon as you remove this aldehyde from this reaction. But when you react with methanol, suppose methanol in HCl, it is because it is already in the hemiacetal form. In the hemiacetal, this OH group is there. In case of any aldehyde, common aldehyde, what we find first of all hemiacetal, because this is already hemiacetal. So this OH group will react with methanol, giving us OMe also here in the alpha. Beta position, also in the alpha position. So we get two, alpha methyl glucoside and also beta methyl glucoside. So both are optic. When you react with acetic anhydride, now you find this is the reason why glucose pentacetate. It does not react here. It reacts in this form, this ring form. So we find here OSC, OSC here, OSC here, OSC here. But once this group is blocked, now this is not going to be reversible. It's not going to come back to this. So it does not open up. Once it is, this anomeric OH group is blocked, then the reversibility is stopped. It does not go open up to give you this. So we do not have this reaction of aldehyde group here. So here pentacetate means what? This is there. The OAC is here, here, and here. So glucose pentacetate is this. So here this glucose pentacetate does not have any free aldehyde group because it is also not going to give you the open chain form. So as a result, it's not going to react with NH2H. So this was one of the anomalies we have considered, but it is not an anomaly because it is structure that is going to. And another reaction I have given here, that is your dimethyl sulfate. Dimethyl sulfate, when we react with this one, all the methyl group gets sulfated, methylated. Sorry, not all the methyl group, rather all the OH group get methylated. So this is a methylating agent, dimethyl sulfate. Another methylating agent is the methyl iodide, but here it is dimethyl sulfate is used. So all the OH group that is there available will get methylated. But when you react with methanol, it is this only the anomeric OH group will be methylated, not other OH group, remember. Because this anomeric OH group is something different from other OH group. This is a hidden aldehyde group. Remember, this is a hidden aldehyde group also. This OH group is different from other OH group. So this is a thing that you should remember. So with this, I finished this. Finish means we have to. There was an interruption here, so there is. I don't know whether this today's lecture is recorded or not recorded. So that I have to find out. So let us come back to this. Screen sharing has been stopped. Okay, all right. So all right. So you'll be given some task and some. I'll forward one of the what is called written version of lectures that we have given till now. The video lecture, whether it is possible or not possible, I don't know. If it is there already recorded, then I'll give it. Otherwise, you have to depend on it. So, is there any problem? Have you understood?
Yes, sir.
But you practice all these structures that I have given today. Alpha glucose, Howard projection, beta glucose, the reactions, then why this, what is the anomalies that we have seen earlier, how these anomalies are. And you see, when it is open, what is in the solid state, how it is existing in the ring form only. And in the ring form, what we see, there is no aldehyde group. So IR spectrum cannot show any aldehyde group there. There is no possibility. So all the anomalies that we have seen earlier has been answered by this. So there are some, it's very simple chemistry as I say, but it is also a tricky chemistry. So you have to know that trick and how to remember the structure, you have to develop your own trick. So this is what is there. So you have your next class. So I end this class, you go for. Okay, all right. All the best. We'll meet
Thank you, sir.
next class.
Thank you, sir.
Okay, bye.